Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be looking at series and summation notation. So let's go ahead and begin by defining what exactly is meant by this word series. All that a series is that it is the sum of the terms in a sequence. So take, for example, if we had the sequence 2, 4, 6, 8, then the series would be 2 plus 4 plus 6 plus 8. That would be the corresponding series for that sequence. Similarly, for this next sequence, it would be 4 plus 8 plus 12 plus 16, and then adding every term that comes after that. I can see that this sequence continues even beyond 16. So it would be adding all those terms together. And lastly, this final sequence with, yes, fractions would be expressed as a series as 1/3 plus 1/6 plus 1/12 plus 1/24, and so on and so forth. And what we are going to be working with predominantly here to begin with are partial sums. We're going to be looking at these partial sums, which is just the sum of a specific number of terms. So we're going to know when to stop is essentially what I mean by that. Like we see here, we're going to find this partial sum for the sequence 2, 6, 10, 14, 18, and what we want to find is the sum S7. Now, what exactly does that mean? We'll take a look in the margin here with me. The S is the way that we will represent the series, and then this little n is going to tell us how many terms we're going to be adding. The n tells us how many terms to add from the sequence. So that is a really big and important thing that we are going to want to be aware of. Ooh, that was crooked. Let me try again. There we go. Okay, so we want to find, like it says, S7, so the sum of the first 7 terms. So far we've got, let's see, 1, 2, 3, 4, 5. So we're going to need to find the next 2 terms. What seems to be happening here between each of these terms, ladies and gentlemen? What is our pattern? Each time it looks like we are adding 4, so the next 2 terms would be 22 and 26. And so let's go ahead and see, what is that? Grab a calculator, add those together. What is this partial sum? Yeah, that would be 98. 98 is our partial sum for this sequence. All right, let's look at example number 3. We want to find the partial sum up to the position 10 here. We want to find the series sum for the first 10 terms. Right now we have 1, 2, 3, 4, 5, 6. So we're going to need the next 4 terms. This is a sequence that we've seen before. It is called the Fibonacci sequence. So what are going to be the next 4 terms in our sequence, this Fibonacci sequence? We're just taking the 2 previous terms and adding them together. So our next one would be 5 plus 8, which is 13. Then we would be adding 8 and 13, which is 21. Adding 13 and 21, which is going to be 34. And then adding 21 and 34, which is 55. And if you guys will go ahead and add those together, what is this partial sum? Adding those 10 terms together, we would have a sum of 143. All right, now, what if instead we are not given the terms, but we are given the formula for our sequence? This is the explicit formula here, and we want to find S5. Well, if we're given our formula, we can go ahead and figure out those terms. We can think of this as like finding what is A1 going to be. Well, that would be the same thing as just taking 1 and plugging it in. So that would be 1 cubed, which is 1. Finding our second term, which is going to be 2 cubed, which is 8. Finding our third term, which is 3 cubed, 27. Finding our fourth term, which is 4 cubed, that is 64. And then finding our last term, because we just want to find our sum up to the fifth position, and that is going to be 5 cubed, which is 125. So what is going to be the sum of those first 5 terms, ladies and gentlemen? Take a moment to determine that. That is 225. Now, why don't you all try to find the sum for example number 7? We're finding that partial sum of the first 8 terms in this sequence. I know I'm going up to 8 because, like I've highlighted here, it is the series S8. So we want to find the sum of those first 8. You're going to need to begin by finding the first 8 terms and then adding them together. Those first terms in order would be 4, and then 1, -2, -5, -8, -11, -14, and a -17. And when you take and add all those together, the result is -52. That is our partial sum here for example number 7. Now, there's another component here in this lesson that I want to discuss, and it is using summation notation. Using summation notation. It is just a way to represent a series using the Greek letter sigma, that's how we read that Greek letter, to denote the sum that we're finding. And it's got all these little parts to it, so let me explain. Down here underneath our sigma, that is the first term. That represents the first term number. So we're going to begin this at 1, where our first value for n is 1. And at the top of your sigma, that represents the last term. That represents the last term in your series. So this series goes from 1 to 5. And what is it that we're going to be doing from 1 to 5? Well, we're going to be using this part over here on the right of our sigma. That is the formula. So what comes after that Greek letter is the formula for the sequence. So this is just a really wonderful way to notate our series that we are trying to find, and it is very clear for us the formula and the like how many terms we're going to be working to add together. So let's go ahead and find the sum of our series above. The formula is just 2 times n, where n is the position. And where are we beginning? We're going to begin at we're going to begin by taking 2 and multiplying it by position 1. Then 2 times position 2, 2 times position 3, 2 times 4, and last 2 times 5. I'm going to stop at 5 because that is what is indicated at the top of my sigma as my last term. So adding all those together, 2 plus 4 plus 6 plus 8 plus 10 is 30. I love using this notation. I think it just really makes it clear the series that we're trying to compute. That is all for this lesson today. If you guys had any questions, will you please take a moment to share those now? And until next time, stay fired up, you guys.